All right, so this is part two of lesson 9D, and we will start by with the definition of mutually exclusive. So, what are events that are mutually exclusive? What does mutually exclusive mean? Mutually exclusive means that events cannot occur at the same time. Okay, so when we use the words mutually exclusive, that means they cannot happen at the same time. So, mutually exclusive, I'm going to say events. Make sure to write this down that cannot happen or cannot occur at the same time or simultaneously. Okay. Now, what do we need from this? Basically, mathematically, what's the significance of this? The significance is that the probability of A and B is equal to zero. Okay. So that means the chances that A and B happen at the same time is zero. And this is normally, sometimes it could be represented by a Venn diagram where you have event A like this, event B like that, and they don't have anything in common. They don't have an overlapping area. So the probability of A and B, well, there's no A and B. There's no, area that is common A and B. So the probability of A and B is zero. Okay, now let's try to apply it here. The question says, consider the following events from the card deck, queen and king, queen and king. So what is the probability you have a king and queen? When you draw a card, you cannot draw king and queen at the same time. So chances are zero. You have zero cards that are king and queen at the same time. Now, how many cards are queen but not kings? Well, queens and not kings is four, right? There are four queens, and the total from that is four. Now, remember the total for the cards is always 52 here, right? The big total on the bottom right. Now, how many cards are not queen but they are kings? Well, that's just basically the kings, which are four of them. And how many cards are not kings and not queens? That's pretty much the rest of the cards. So far we took 8 cards out of 52. And this leaves us with what? This leaves us with 44 cards. And then here the total from this line is 48. Notice how these two add up to 52. And here the total is for all the kings. All the not kings is 48, and so on. So now that we have all this information, remember these are not the probabilities, right? These are just the number of cards. Now that we have the number of kings and queens and the entire number of cards, the question is, are queen and king mutually exclusive? So is it possible for queen and king to happen at the same time? Yeah, well, it's not possible. So they are mutually exclusive. That means it's not possible for them to happen at the same time. How do you explain that? Probability of queen and king is equal to zero out of 52, which is zero. Now, your friend draws a card and claims that the card is both in queen and king. What would you tell them? Well, that they are not being honest, right? Honest instead of lying. So that they are not being honest, right? Or maybe they're like a wizard, right? So for part C, sketch the Venn diagram for the situation above. This is basically the event a queen, Q for queen, right? So, and there are four of them. And if I were to do the kings, and again, nothing, right? If I were to kind of do everything else, there are 44 other cards on the outside. Now, and then think carefully about how you draw the circles. We kind of did that, right? So we call sometimes, we sometimes call these events. So remember we said they're called mutually exclusive. we also call them joint. Okay, this joint, that means disconnected. Okay, so look at K and Q, they have nothing in common. So example 3, the question says, so now determine whether the following examples are mutually exclusive or not. So we're gonna say ME for mutually exclusive or not ME for not mutually exclusive. Remember, mutually exclusive means they have nothing in common. Not mutually exclusive means they have something in common. A large political gathering, at a large political gathering, you select a person at random to determine if the person is a Republican or over 50 years old. So this is not mutually exclusive because these two things can happen at the same time. Large political gathering is with the person at random to determine if the person is registered Democrat or Republican. That would be mutually exclusive. Because if they're registered Democrat, they cannot be a Republican and vice versa. Now flip a coin to determine if you get a heads or tail. That's mutually exclusive because you cannot get a head or tail at the same time, head and tail at the same time. Roll a die to determine if you get a 4 or a 6. That's also mutually exclusive, right? Because 4 and 6 cannot happen at the same time. Roll a die to determine if you get a 3 or an odd number. That is not mutually exclusive because 3 itself is an odd number. Draw a card from a standard deck of cards to determine if you get a queen or heart. That's also not mutually exclusive because it's possible for the queen to be the queen of hearts. And then lastly, determine a chord. And we can, these are good examples, right? You can understand mutual exclusive or not. A chord from a standard deck of cards to determine if you get a black chord or a diamond. Well, you cannot have this both of these at the same time. So if a card is black, it cannot be diamond, and if it's a diamond, then it cannot be black. So these will be mutually exclusive. As example 3. For example 4, let's move on. It says after team tryouts, 40% of the players were placed on A team. The others were placed on the B team. 80% of people who tried out were returners to the program. That means they played last year, and however, 5% of the players were both new to the program and made the A team. So we have some information here. Do you think if a player is a returner, they will automatically make A team? So how do you think of this? So again, we had tryouts. 40% of the players were placed on the A team, and then the others were on the B team. I mean, 60% players, right? And then we have 80% of people who tried out returners. However, 5% of the players were both new to the program and made the A team. So for us to be able to answer these questions, I think let's try to fill out the table first and go back to the question. So let's try to do C. Keep in mind that here we have defined what A is made the team, and A prime would be not made the team, or would be returning to the program, and R prime would be not a returner, which means they're new to the program. So let's put the numbers based on the numbers that we have. Let's fill them in here, right? What do we have? So for we said 40% of the players were placed in the A team. So that's 40%, which is 0.4 right here. 0.4, right? And remember, this is going to be 1 here. So, now, they said, however, 5% of the players were both new to the program and made, so they were new to the program and what? And made a team. So this is 0.05 or 5%. They were new, not a returner, new and a team, which means returners and A were whatever completes that to 40 because or 0.40 because these two add up to that. Okay, now what else do we have? We have 80% of the people tried out were returners. So the total returners is this. That's 80% of the total, which makes this 0.45. And now if this is zero point 0.4, then this is zero point 0.6 to get a total of 1. And if this is 0.45, what do I need here to get zero point 0.6? I need 0.15. And notice how this is 0.1 now, and this whole thing is 1. Okay, so this is how you handle these types of questions, right? It's like you find one or two answers and then the domino effect. So to go back, do you think if a player is a returner, and that was a question basically asked before really filling out the table, do you think if a player is a returner, they're basically saying if a player is a returner, if they're here, they will automatically make the 18, which is here, right? Well, if they're here, 0.35 out of the 0.80 really. Right? So they will not necessarily automatically make the 18. So, right, it's not a, this is a chunk of that, but it's not really a big chunk of it. So not necessarily, let's see here, now this, and then part B, do you think players placement in A on the 18 is independent of whether they were returners? So we're trying to find probability of A. And we know that the probability of A and not returners, this is A not returners right here, is 0.05. So, and we need to compare it to what the probability of A and the probability of not returners. Probability of A is 0.4. Probability of no returners is 0.2. You multiply those two together, you get 0.08. And you know this is not equal to 0, which is basically the probability of A. The probability of not R. So therefore what? How do we say that? We would say not independent. Okay, and then part D. So the events returner and not making seeming mutual exclusive. So how do we do that? We want returners and not making. Returners and what? Not making. Where's that? That's returners, which is here, not making. So that's right here. That's 0.45. Right? Now, what are we saying here? We're saying returners and not it's there's something, right? There's like an overlap. So this is not equal to 0. Because if it was 0, there would be not there would be mutually exclusive. But this is not equal to 0, so you're going to say not me, not mutually exclusive. That means they have something in common. Actually, they have 45% in common, right? So so just keep that in mind algebraically. And then finally, after being a returner and making the team A independent, sorry, I'm sorry, or being a returner and making the team A independent. So one returner and team A. Well, what's the probability of returner? That's a total return, which is 0.8. Making team A, that's a total from whatever, which is 0.4. So we're being asked if these are independent. And how do I justify? I want to compare probability of R as a probability of A. I want to compare it to what? To probability of R and A. I know the probability of R and A, that's where R and A meet. And that's this, which is 0.35. And I know the probability of R times the probability of A. That's the total from R and the total from A, which we just had. That's 0.884. And these are not going to be equal because really the left hand side here is 0.32 and the right hand side and they're not the same number. Okay, so how do we say that? The question was, are they independent? So we're gonna say they are not. They're not independent. So how do we think of this? Remember, we're talking returners and team A. Right? So how do we say that? So it's in it part of the placement on the team will depend whether you return or not, right? Like if you don't, right, part of the placement on the team really is dependent on whether the person returns or not. If they return is one thing, if they don't return, then it's also another thing. So this is justify mathematically we did that. Describe how this information is important to the returners. So part of the placement is dependent on the team. On what? On whether or not what the person returns. Okay. So let's pause here for now and make sure you complete these notes and move on to the Delta Math assignment. And remember, it's due today. The Delta Math assignment is due May 5th, and it covers 9A through 9C. Some of you already completed it. Good job. If you're done with that, you can move on to studying for the upcoming group quiz, which will be on Friday, and which covers lessons 9A through 9D. Thank you.